Hello everyone, this is our review sheet for Unit 1 exam. For Tuesday we're going to take our exam, and this is the review sheet that I handed out on Thursday and Friday. For those of you who weren't at school on Friday or Thursday, then you can find this review sheet on our calendar for Thursday, Friday. The way I recommend using this review sheet is to treat it like a practice test. If you haven't already done that, then turn off this video. Take about an hour just to go over the review sheet as a practice test. So that means no notes or anything like that, just using what you know and a calculator to do the work. And then once you've done that, you can compare what your answers are and then watch this video and then just go through it that way. I think it's going to be really helpful if you do it that way. It'll help you focus on what you need more work on. Okay, but for the rest of you who are ready to go over this review sheet, let's start. So we have here a position time graph, and it's asking for us to calculate the average velocity and then also write out the mathematical expression or the mathematical model. If you guys remember, and hopefully you all do, the slope of a position time graph tells us velocity, and that equation is this right here. It is delta x over delta t. It's our slope equation. It's also our velocity equation, so you can see where those come in handy, or you can see where we get those equations from. So what we're going to do is just pick 2 points along our best fit line on our position time graph and call one position and time our initial, and then the next point, our time and our position, are going to be our final time and final position. And then we're just going to put them into our equation. So I've already done that here. I've marked off 2 spots. You can choose any 2 spots you want. I usually choose the easiest 2. Usually it's the beginning and the end of the line, and I've done that if you can see that in pink highlight. So the 0, 10 right here, that is our initial time and our initial position. Here, our 6, 60, this is our final. This is our final position and our final time. So let's just put that into our equation. Let me kind of scroll this down a little, and then we'll solve. So our final time and final position. Our final time is 6 seconds, and that goes on the bottom. Our final position is 60 meters. Minus our initial position and our initial time. So our initial position is 10 meters, and I'm getting that from right here. And our initial time is 0 seconds. Then you just do the math, right? Easy. 60 minus 10 is 50. And 6 minus 0 is 6. And I end up with about 8.333, and those 3's just continue. So I would recommend always rounding to the hundredths place, unless I mention on the question or the test to round to the tenths place. So if you round it to the hundredths place, it's 8.33, and don't forget the units, meters per second. So that is our slope or our velocity, average velocity of that graph. Okay, so the next part is asking you to write the mathematical model, and we've already done one part of it. We've calculated the m, or the slope, right here. We just did that, and we know it is a linear equation that we're going to use because our graph is linear. So our y variable is x, or position. I recommend writing it as x instead of spelling out position. Don't use m, because m is the units for position, and that's not what it's asking for. It's asking for the variable. And it's equal to m, which is our velocity or our slope, and we calculated that to be 8.33 meters per second. And multiplying that by the x variable, and our x variable is time. Again, it's not seconds, because seconds are the units of time. And we're going to add that, or it's plus b, and our b is our y-intercept, which is right here on our graph, and that is 10 meters. It's where our line goes through the y-axis. So there you go. That's your mathematical model. You could use this equation or this mathematical model to solve for the position at a specific time. I mean, any time. It doesn't have to be between 0 and 6. If this line was to continue on, right, it would continue on exactly the same way. So if you're saying you want to figure out what your position is, at 24 seconds, you just plug in 24 for t and then do the work, and it will give you the position at that time. Okay. Number 2. Shown below is a velocity time graph for an object. Describe the motion of the object. So I already wrote out the values of the velocity and for how long it's going for each part of this graph. So, my son at the door. Okay. So, for the first 2 seconds, it's going 4 meters per second. And that's that line right there in pink. It shows it's at the y axis where it says 4 meters per second. And from 2 to 3 seconds, it's at the -3, or the -3 meters per second. That's the y value. And it's going -3 meters per second for 1 second. And then from 3 seconds to 5 seconds, it's at 0. And so it's going 0 meters per second for 2 seconds. So we can't mention anything about its starting position because on a velocity time graph, that information's not given to us. But we can comment or describe the velocity and how long it's going and stuff like that. So let's just start off with that. So you can start this off by saying the object's initial velocity is 4 meters per second positive. And you can state this any way you want, right? You could say that the object has an initial constant positive velocity of 4 meters per second for 2 seconds, right? As long as you include that its velocity is constant. So I should put that there. Object's initial constant velocity is 4 meters per second positive. So as long as you say it's a constant velocity, positive 4 meters per second for 2 seconds, that's what's important. Then changes direction and travels at a constant velocity. That's what the CV here is. Sorry, I'm just trying to shorten this up. Travels at a constant velocity of -3 meters per second for 1 second. That's the green part here. And then stops. And remains at rest for the remainder of the time. Okay, sorry, I'm still trying to figure out how to write on this the best I can or make it nice and neat. So what does it say? It says the object has an initial constant velocity of 4 meters per second positive for 2 seconds. Then changes, that's what this word says here, changes direction and travels at a CV constant velocity of -3 meters per second for 1 second, then stops and remains at rest for a remainder of the time. There you go. That's exactly what it is. So next it's asking us to draw a corresponding position versus time graph. Number the axes. You may assume the object starts from 0 position. Because remember, in a velocity time graph, it does not give us any information about its starting position. Okay, so I will always include the starting position when you have to take information from a velocity time graph and transfer it into a position time graph. So what do you want to do? You want to label your axes, and I've already done that just to save time. But when you're doing that, you have to make sure that however many seconds are accounted for in the starting graph, that your corresponding graph has the same amount of time. One problem that really came up on our last quiz was that a lot of you guys forgot or didn't represent the correct amount of time. And remember, you don't have to always number these axes in units of 1. You could go 2, 4, 6, 8, 10, right? Whatever you want, as long as they follow the same intervals. And what I mean by that is, like, you can't start on this first line as 2 and then the next one be 6. And so right there, 2 and 6, the interval between those are 4. So that means that the next one would have to be 10, right? So it couldn't go 2, 6, 8 or 2, 6, yeah, 8, 12 or whatever, okay, to have to go in the same intervals. I hope that makes sense. Okay, so if our starting position is 0, that means we can put our initial point here at 0. And so let's just look. At the start, it's going 4 meters per second for 2 seconds. So how far does it travel in 2 seconds? Well, in the first second, it's gone 4 meters because it's going at a rate of 4 meters per second. In the second, it's gone another 4 meters. So its position at 2 seconds is 8 meters. The next part, right here, the green part on our velocity time graph, it says it's going -3 meters per second for 1 second. That means our line is going to go in the opposite direction. Now it's going to go down. It's not, I shouldn't say down, but it's going to head back to the origin. So it goes from 8 meters to 5 meters. So at 3 seconds, it's at 5 meters. Then for the remainder of the time, it doesn't move. Remember, it stops. It says right here, it stops and remains at rest for the remainder of the time. And that's represented here in orange. So if it stops and it remains at rest for 2 more seconds, that means its position doesn't change. And those are the dots that we have there. So 0 to 1 second, 4 meters. 1 to 2 seconds, another 4 meters. 2 to 3 seconds, -3 meters. So it's going back. So it's going to 5 meters. And then it stays there for the remainder of the time. So let me just make that line that out. Right? Sorry, it's not perfect. Okay, so now your next question we'll see is asking you, how far did the object travel in the time interval of 1 second and 2 seconds? So let's just look. So from 1 second, right, that's this right here, to 2 seconds, how far did it travel? Well, it went 4 meters. And then D is asking you to tell us to find, well, it's asking to find the displacement from t equals 0 seconds and t equals 5 seconds. So we're calling t initial is 0 seconds and t final is 5 seconds. So to find displacement, it's just delta x, which is x final minus x initial. So match up the position of x initial, which is t equals 0 seconds. So what is your position at t equals 0 seconds? Well, it's 0. So our initial is 0 meters. And our final, what is it at 5 seconds? What is our position at 5 seconds? It's 5. So what's our displacement between 0 seconds and 5 seconds? 5 minus 0, 5 meters. All right, you guys, I'm going to stop there, and I'm just going to finish up with the remainder of this in the next video. Hopefully this is helping you guys. And be sure to email me and ask me any questions. We'll also have time tomorrow to review. I have actually a really cool way we're going to review tomorrow. So it's not Kahoot, so I hate to burst your bubbles on that one, you guys. Okay, well, have a good day, and I'll continue these videos.